we are going to learn about measurements and redox reactions. What are the content today? We are going to see is introduction, physical quantities, units, fundamental quantities, rules for writing SI units, small scale measurements, measurement of mass, and then conclusion, and then redox reaction. Introduction. Then what is meant by measurement? Measurement is the basis of all important scientific quantity. It answers questions like how long, how heavy, etc. Measurement is defined as the determination of the size or magnitude of a quantity, that is, giving a number or designing or assigning a number to a quantity or characteristics of an object or something else, like 5 centimeter scale, 1 liter water bottle. So the 5 centimeter and 1 liter represents the measurement. Then what are physical quantities? It is a quantity that can be measured. They are classified into two: fundamental quantities and derived quantities. Fundamental quantities are quantities which cannot be expressed in terms of any other physical quantities, that is length, time, mass, etc. Derived quantities. These are the quantities that can be expressed in terms of fundamental quantities. Example, area and volume. That is, if the area we represent in terms of side into side. If we take area of a rectangle or area of a square, we will be writing as L into B. So length is a fundamental quantity and breadth is also a fundamental quantity. So we can write the derived quantities in terms of fundamental quantities. Then units. A unit is defined as a specific magnitude of a physical quantity that has been adopted by law or convention. Several system of units that are we following, that is CGS system, FPS system, MKS system, and SI unit system. CGS system means centimeter, gram, second. FPS system means 4 pound second. MKS system means meter, kilogram, and second. SI system, that is we use all through the world, that is international system of units is used worldwide. Then fundamental units. Units used to measure the fundamental quantities, example the length, mass, and time, are called as fundamental units. That is, for length, the SI unit of length is meter, m. We represent it as m. And mass, the SI unit of mass is kilogram, kg. Then time, the SI unit of time is second. Then temperature, SI unit of temperature is Kelvin. Some rules for writing SI units are: small letters are used, example m for meter. So we have to use the small letter m, not the capital letter. Then not expressed in plural form, that is if we want to write as 10 kg or 20 kg, we should not write it as 20 kgs gs. We should write only as 20 kg alone. We should not write it as 20 kgs. Then accepted symbols alone should be used, that is, for example, second. Sometimes we would have made mistake, like us we will be writing as SEC or SECA seconds, like that. So we should not write like that. We should write like second. Second should be written only as S, that is the symbol is S, that is not SEC. Then no full stops or other punctuations should be used after symbols. 50m and not 50m dot. Units named after scientists are not written with the capital initial letter, that is Henry. Example, Henry. Then small scale measurements. For measuring small scales, we use some of the instruments. That is, some of the examples here given are vernier caliper. Vernier caliper is used to measure the depth of hollow objects and small scale measurements. The least count of vernier caliper is 0.001 centimeter. Nowadays, we are using, in the recent days, we are using digital vernier caliper, in which which has digital displays on the slider and displays the measured value. So we need not to calculate the errors, and we need not to subtract or do manual calculations. So here no manual calculation is required. Then screw gauge. These are the pictures of vernier scale and screw gauge. Similarly, screw gauge is also used to measure the diameter or thickness of the coin, the thickness of the string or wire or hair, like that. So screw gauge is used to measure the diameter of a thin wire and thickness of thin metallic plates. The least count of the screw gauge is 0.01 millimeter. Then, measurement of mass. Today we are using various types of balances to measure the mass. Common balance, physical balance, digital balance, spring balance. So common balance, it compares the sample mass. It will be having the sample mass in one side with the standard reference mass on the other side. If we would have been seen in vegetable shops like that, the vendor will be using some balance, no. So he will be having some sample mass of 1 kg, 2 kg in one side, and he will be measuring the vegetables on the other side. So it is a example for common balance. Then physical balance is used in labs. Then digital balance measures mass accurately up to few milligrams. So in jewelry shops and all, we will be using it to measure in grams, milligrams, no. So that they will be using the digital balance. Then spring balance. In the spring balance, at the end of the, it will be having a hook like structure. At the end of the hook, we will be hanging the material that should be the material of the mass of the material that should be measured will be hang on the hook, and it will extend. So the spring extends according to the weight attached, and the pointer reads on the scale. So likewise we can measure the mass of the object. Then the conclusion about the measurement is measurement and measuring instruments are important aspects of science as well as in our daily life. So if we measure any quantity wrongly, it will be not good for us. So measurement and measuring accurately with the proper instruments is important in our daily life. So it is important to be accurate when taking measurements. Then we will be going to see about redox reactions. Redox reactions, it denotes a coupled reduction and oxidation reactions. So here there are of two classes. Electron transfer, only one electron flows from the reducing agent to the oxidant. Atom transfer takes place here. So reduction means if an atom gains an electron, it is called it is gaining an electron, and it has become more negative, so it is reduction. And oxidation means if it loses some electron, if an atom loses an electron, then it is called as an oxidation. So in a chemical reaction, if both the reduction and oxidation reaction takes place at a time, so it will be called as redox reaction. That is coupled reduction and oxidation reactions. So it is an example. So first, in this chemical reaction, the reduction reaction also takes place, and the oxidation reactions also takes place. So these are some of the references that we can follow for future references. Thank you.